Alright, so in this video, I'm going to solve the equation a to the power of 3 plus a squared is equal to 80. So my only variable in this equation is a, so that's what I'm going to be solving for. And now for my solution. I'm going to first start by rewriting my equation down here so I have a little more solving space. So my equation is a to the power of 3 plus a squared is equal to 80. So if a to the power of 3 plus a squared is equal to 80, and I can subtract 80 on both sides, and now I get that a to the power of 3 plus a squared minus 80 is equal to 0. So what we can't do is use the quadratic formula to solve this because this is not a quadratic equation. We have a power of 3 and a power of 2, and we're also missing a power of 1. So instead, what I'm going to do is rewrite negative 80 as negative 64 minus 16. And the reason I did this is because negative 16 is the same thing as 4 squared, negative 4 squared, and negative 64 is the same thing as negative 4 to the power of 3. And notice how I have a number cubed and that same number squared, and again I have a number cubed and that same number squared. So now I'm going to group the cubes together and the squares together. So I have a to the power of 3 minus 4 to the power of 3 plus a squared minus 4 squared. And now I'm going to use two different properties. So the first is that if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. And now if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So we're going to use the first one on a to the power of 3 minus 4 to the power of 3, and the second one on a squared minus 4 squared. So a to the power of 3 minus 4 to the power of 3 is going to equal a minus 4 times a squared plus 4a plus 4 squared, which is 16. And a squared minus 4 squared is going to equal a plus 4 times a minus 4. So I get a minus 4 times a squared plus 4a plus 16 plus a plus 4 times a minus 4, and this is equal to 0. So there obviously is a lot to this equation, but we can actually simplify this by factoring out the greatest common factor. So notice how both of these terms have a minus 4 in them. So if I factor out a minus 4, I get a minus 4 times a squared plus 4a plus 16 plus a plus 4. And now to simplify this, we can add like terms. So a squared plus 4a plus 16 plus a plus 4. Well, 4a and a, we can add these. 4a plus a is 5a, and 16 plus 4 is 20. So I have a minus 4 times a squared plus 5a plus 20 is equal to 0. So this gives me two equations. I get a minus 4 is equal to 0, and I also get a squared plus 5a plus 20 is equal to 0. So for a minus 4 equals 0, I can add 4 on both sides. So then these two cancel out, and I get a equals 4, which is one solution to my equation. And now for a squared plus 5a plus 20 equals 0, because this is a quadratic equation, I can use the quadratic formula to solve this. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now a is 1, b is 5, and c is 20. So I get a equals negative 5 plus or minus the square root of 5 squared minus 4 times a, which is 1, times c, which is 20, all over 2a. And this is equal to negative 5 plus or minus the square root of 25 minus 80 over 2, which is equal to negative 5 plus or minus the square root of negative 55 over 2. So we have the square root of negative 55, and I can rewrite that as the square root of 55 times the square root of negative 1. And if you guys already didn't know, the square root of negative 1 is equal to the imaginary number I. So I get a equals negative 5 plus or minus the square root of 55 times the square root of negative 1 over 2, which is equal to negative 5 plus or minus the square root of 55 I over 2. So this is another solution for A. So I have in total 3 solutions, 2 imaginary and 1 real. So now my final step in solving this equation is to check to see if my answer is right. So my equation is a to the power of 3 plus a squared is equal to 80. And we got that a equals 4. We can't check our imaginary solutions, so we can only check our real solution. So if a equals 4, I get 4 to the power of 3 plus 4 squared is equal to 80. Now 4 to the power of 3, that's going to equal 4 times 4 times 4, which is 64. So I get 64 plus 4 squared, which is 16, is equal to 80. And 64 plus 16 is 80. So I get 80 is equal to 80. And because this is right, we know that our solution a equals 4 is right as well.